Very good morning. Very good morning. Uh, so we have how many papers in total? 1, 2, 3, 4, 5, 6. One of these is a short paper, others are full length papers. Good. And a couple of online presentations. Fine. So welcome you to this session, which is the technical session of track C. In the first paper is Conto, an AI-driven smart glove for enhanced sign language communication. The presenting author is Devaditya Ghosh.
A very good morning, sir, and honorable members and professors present here. Just a second. Start with a very simple exclamation about the presence of deaf and mute people in India. So in a country like India, where there lives more than 63 million people who are at a spite of hearing loss, we have less than 350 certified sign language interpreters, which is an really unfortunate statistics. But ironically, the people who we call deaf and dumb are not dumb because they can't express themselves. In fact, we call them dumb because we are the ones who can't understand their language. This paper introduces Control, an affordable, multi-sensor, LLM-backed ensemble-powered glove, which paired with a mobile app promises real-time gestures to speech and speech to text conversion. To bridge the gaps of communication for the deaf mute population, enabling them to fully participate in society and improving their chances for employable and educational opportunities. Let's go to the next slide. Here are our objectives and hypotheses. So our objectives are very clear. In fact, this is not the first time there's a product like this, gloves. This has been done before. It's there in the market. But what is our novelty we present in front of you? That is, we are using bidirectional deaf-mute communication. We are promising seamless bidirectional deaf-mute communication and the use of LLM in order to maintain and construct sentences which are incomplete or incoherent in nature. So let's go to our literature review, which we have done. So we have covered extensive literature reviews and have come to some findings. So in case of some sensor-based systems that used Arduino Mega, flex sensors, accelerometers, SD cards, there are limitations. Limitations such as direct sensor data processing, which leads to majorly inaccurate ASL translations, American Sign Language translations, in fact. When we went to study computer vision-based technologies, we found there were two major problems in hand. Number one was the struggling with 3D hand rotation and dynamic gesture recognition. Also, there was a problem with detection of skin color separation during low light. So arranging for cameras that can maybe track thermal detections or low light cameras was tedious for us. However, There were two major existing technologies in the market before us, which were sign aloud and write sign. The problem with sign aloud is that it can convert gestures to speech or text, but lacks two-way communication, and its high cost result in reduced accessibility. On the other hand, bright sign gloves is another established product that enables two-way communication but has problems with extremely high cost, over 2 lakhs, hence is not accessible to common people. And both of them doesn't use LLMs in order to form coherent sentences in case there is an incomplete or incoherent sentence formed. So these were our major points to build something new. So our main novelty, keeping in mind, is doing all of this while keeping the price affordable. And honestly, what we have built is under the price range of 6,000 rupees. So let's go into how we designed our hardware. So our hardware design consists of 5 flex sensors over 3 joints of our fingers and using one custom built EMG sensor and an MPU 6050 that works as an accelerometer and gyroscope both, so that it can take 6 inputs, X, Y, Z axis for the accelerometer, and in order to calculate the angular velocity, the 3 axis, that is roll, yaw, and pitch for the gyroscope. All of them are handled by an ESP32 microcontroller, and the readings are sent to the mobile device using Bluetooth, where an app is built using MIT's App Inventor tool, which sends our readings to a Flask server hosted in AWS EC2, where the machine learning model is present to predict the English words from sign language gestures. These outputs from the models are sent back to the app, where the LLM checks if the sentence formed is coherent or complete or not. Let me explain it with the working flowchart. You can see here that the readings from the flex sensors and all the other sensors are sent to the ESP32 microcontroller, where the data is relayed over the Bluetooth to an Android application by ESP32, where an API request is sent in order to the Flask server, where the deep learning model, where the machine learning model is hosted with AWS, which sends back a prediction for the ASL gesture to text. So these outputs from the models are sent back to the app, where the LLM checks whether the sentence formed is coherent and complete or not. If no, it makes it so. And the results are turned to speech via Google text to speech and spoken out of the speaker. Reverse communication is done by Google's speech text module. Let's now discuss about the role of LLM in our product. Well, it's used to address challenges like incoherent or incomplete sentence formations. The application integrates an open source large language model that's told previously, Llama 3 8B, that is hosted on Grok, using Grok's LPU, that's language processing unit, for ultra fast and low latency processing. Then, pure short prompting method has been used to refine our incoherent input text instead of fine-tuning due to our project deadline. This refined text is then converted into speech using Google's text-to-speech engine. Let's go to our model. Well, this is very interesting. As our data is collected from 12 different sensor inputs and has more than 2 labels, it can be classified as multi-class classification problem. For this task, we have selected a stack generalization ensemble model with cat boost classifier serving as its final estimator and random forest classifier, XGB classifier, and SVC, that is support vector classifier, as its base models. Now, why did we choose these specific models as base models? There are reasons. Let's begin with the variance versus bias trade-off in ML, where variance is the sensitivity of the model to new data during training, And bias can be said as the inability of an ML model to capture its true relationship with its data. Low bias and high variance results in what we know as overfitting, which we don't want in our model. To solve this, the mostly used methods are bagging, boosting, and regularization. So now we are utilizing random forests to deal with bagging, which is done in two steps: bootstrapping and aggregation. During bootstrapping, we have used three random feature selections to build our decision trees, which reduces correlation between the trees and hence reducing overfitting. For regularization, we are taking help of support vector machines to find the perfect plane for our support vector classifiers. Well, we know SVMs use kernel tricks to systematically find SVCs in high dimensions. Here, we have used the radial basis function as it can find SVCs in infinite dimensions. Here, we are needing 12 dimensions for our particular project. RBF behaves like a weighted nearest neighbor model. That means it gives precedence to the nearest data points rather than further data points to classify. Well, finally, CatBoost is used as our final estimator because it avoids leakage, which can lead to overly optimistic model performance and hence overfitting. It does so by using ordered target encoding, which feeds each row sequentially into the algorithm one by one in order to get the results. Well, that's the results we are talking about. Now, I would like to show you this comparative analysis of ML classifiers, which we have used and tried in our paper. So this was the best classification model that we could find, a stacking classifier that we have used, which has CatBoost as its final estimator with random forest XGB and SVC as base models. We have used 4 columns. One is accuracy, prediction, recall, and F1 score in order to compare them. Another thing we tried was keeping the final classifier, the meta classifier, as a logistic regression model, which, as you can see, provides lower values in accordance with the first one. We have also tried using single models as for comparison, which gives further lower value for both for 4 of the matrices. Our next slide would show us the confusion matrix of the stacking model classifier with CatBoost, which is done by using a lower number of data points, and the importance of features in ASL dataset, having the importance of every ML model and their importance of features accordingly. We move to the next slide. I would like to conclude by saying that the idea is to implement and integrate LLM into a cost-effective, customizable smart glove, offering intuitive and personal communication, making Contour an accessible product for the ones who need it. If we go next, we can see the future scope. For future, we have 3 very clear major improvements we are currently brainstorming. Number 1 is to ensure that hands of all sizes and forms will provide homogeneous values for our models to work with the least chances of noise and error. Number 2 is we believe in function following form. We are selecting materials that are resilient to sweat, dust, direct sunlight, or occasional light rain, so the electronics doesn't get damaged during everyday use. At the same time, we are designing PCBs and reducing bulk from our gloves to make it feel like an extension of our body, so it's easy to use. And number 3 is to do all of this and still keep the price affordable, such that it can cater to everyone who needs it. Thinking of industrial advancements, we are thinking about partnering with healthcare providers and disability organizations in the future to extend the system's reach. We have also thought about reaching out to some NGOs and insurance companies who provide insurances to deaf and mute people, where this product can help bridge gaps in communication, which can make them less prone to unwanted situations, hence being a win-win for both the consumer and the company. Here are my references, which I have used on the paper, 2 pages of references right here. And that's all from my side. I would like to end my presentation with a big thank you to all the honorary members present here, and to Sir Nolin Duchapi for being a witness to my presentation and its product. Thank you.
Thank you. Since we started late, I appreciate the author presented in the time. So we have time for some quick questions, if any. Please.
So this is a really good idea. Thank you so much for your speech. But considering that this has like raw signals, you're using SDHC, you have a lot of APIs.
Right.
How much time do you think a lot of this will take? If the communication is fast,
Right.
how do you plan to keep up?
So what we have done is we know that for XGBoost, it takes quite less time for the model to train, and it also gives a pretty accurate value. So our base models are selected such that the time complexity is less. That's what we are trying to say. And another thing that we have done is we have also for the reducing the noise, we have used z-score normalization. This is a place that we are working on right now to use something better, so that the values that the computer has to deal with may be smaller. The smaller, the better. The computational time will be less. Thank you for the question.
Okay, I have a quick question. I mean, we see that even, I mean, say these tools like Siri and things that the standard companies in their product, they insist on a learning cycle to get the actual voice, so that afterwards those products they work well. So here the application scenario would be like a announcement is going on in a public place. So how do you think that without, I mean, that factor is not possible here, that you cannot train your system with individual voices. So what if how it can affect the application accuracy in the end?
Right. So, sir, if I understand the question correctly, what should we do in order to make the product more user accessible and easy to implement, right? Like
Yeah, I mean, where you do not have a option to customize it for an individual speaker who is giving some instruction to the which is pertinent for the dead person who will get it through your system.
Right, so the promotion basis, right? So what I'm saying is we are focusing on function following form. If my product looks approachable and not like a cyborg tool, the person who will be using it will not be bewildered by seeing it at first, which is, I think, is a major step. Because if I see something like a VR in some your festivals, if I see someone trying VR, meta VRs, that may look a bit too much futuristic for use and not very catered for everyday use. So what we are trying to do is when these people of special class go to hospitals, then they will be, for communicating with the doctors, if you provide them with an easy example to how to use it, and when they use it and get results back, when they can finally see that what the other person is talking in front of them, that will produce a hope, and that can instill a hope to learn more about the product and maybe use it in the future.
Thank you. So thanks again to the author. And, next paper is, thank you. And the next paper is paper 81, which is, does very developer interactions cause bugs to be resolved faster? A study of open source software ecosystems, to be presented by author Reshma Raju.
Morning, sir. A hearty good morning to all of you. I am Reshma Roy Chaudhary and I'm privileged to present our paper, Does Varied Developer Interactions Cause Bugs to be Resolved Faster? A study of open source software ecosystem. So this is a brief outline of the topics that I will be covering today. Now, developers form the core of any software development ecosystem. Developers from diverse background, diverse experience, collaborate together in a team, share knowledge. So this brings us to the important point that interaction among developers is a very important factor and it has the possibility to impact important software outcomes. Okay, this was our motivation into looking deeper into developer interactions. Now, let me clarify here that for our context, for our research, developer interaction means developer co-commenting interactions. Now, these co-commenting activities happen throughout the life cycle of a software development project. But one of the phases when this co-commenting activity is very dense is the bug resolution phase, which is why we have selected the bug resolution phase as the area of our study. Now, typically, it would appear as if the interactions among developers is of only one type, but developer co-commenting interactions can be of various types. And for our research, we have used experience of the developer and familiarity among developers as the classifiers. This brings us to our objective that the first being, we first identify the different types of interactions that can happen for a bug, and then we identify whether a causal relationship exists between diverse developer interactions and bug resolution time. Now, here let me highlight the importance of a causal study. Correlation does not imply causation is something we all know. However, causal studies have more popularity in other sciences, for example, medical sciences. Causal studies in the software context is not so common. Now, one of the reasons could be that it is difficult to use established methods like randomized controlled trials, which are considered as gold standard in the software context. Let me give an example. Suppose live bugs are being logged in a system. We subject some of the bugs to an optimal treatment and some other bugs to a suboptimal one for the sake of an experiment. That's not done, right? So it is difficult. But at the same time, the way software systems impact every aspect of our day-to-day life, it is critical that we conduct causal studies in the software context as well. And that brings us to what we have tried to do. We have tried to establish causal relationship between two very important markers of a software development ecosystem. So there has been past work which delves into how bug resolution time can be optimized, how we can quantify collaboration. We have also seen papers where causal study has been conducted in the testing phase, in fault isolation, but our paper covers something absolutely new. That is, first it looks into developer interaction, and then it tries to establish a causal relationship between our variables of interest. I'll just cover a brief outline of our methodology here. So we begin by identifying the developers who have commented on a bug. And then we try to categorize developers into different experience levels. Then we try to identify whether the co-commenting developers have co-commented with each other before or are they doing it for the first time. And then we characterize every co-commenting interaction with the experience level and the familiarity of the developer. We arrive at a table like this where for each bug, we have identified the different types of interaction, and then we explore our research question whether our variables of interest are causally related. Now let me cover a few aspects of methodology in the next few slides. So first we begin by identifying the developer experience level. For this, what we have done is we have sorted all the developers who have commented in a descending order. And we saw that the top 10% of the developers account for the majority of the comments that has been made in a data set. And this section we have divided into quartiles. So you see, each quartile is one experience level. Okay, so this is this is a data from our OpenStack data set. If a developer has made comments between 1 and 139, the developer belongs to experience level 1. If a developer has made comments more than 139 and below 230, this is experience level 2. So every developer starts out by being a level 1 experienced developer. Of course, it's not necessary that all developers will cross all 4 experience levels. I'll show how we construct the developer network using this example data. So you see in row number 1, when developer 1 comments on bug 1, developer 1 is added to the network. Okay. At row number 2, when developer 2 comments on bug 2, developer 2 is added to the network. At each step, the algorithm makes note of the number of comments made by a developer because that decides the experience level. In row 3, when developer 3 comments on bug 1, the algorithm sees that bug 1 has been commented on by developer 1 and developer 3 and draws an edge between the two. This is the first interaction between them. So this is classified as a fresh interaction. Next, in time T4, when developer 1 comments on bug 2, for similar reasons, an edge is drawn between these two developers. See, bug 2, developer 2, bug 2, developer 1. So an edge between developer 1 and developer 2. At time T5, when developer 3 comments on bug 3, developer 3 is already a part of the network. So no new nodes are added, but the algorithm keeps a record of the number of comments by developer 3. And finally, in T6, when developer 1 comments on bug 3 and the algorithm tries to draw an edge between developer 3 and developer 1, it sees an edge already exists. It increases the weight of the edge and records this as a repeat interaction, not the first co-commenting interaction between the two. So this is our developer network where every edge is characterized by the experience level and the familiarity of the participating developers. Now, these are a few examples. So these two developers, one of level 3 experience, one of level 4 experience are co-commenting for the first time. We label it as level 3, level 4 fresh interaction and so on. So with 4 experience levels and 2 familiarity levels, we have identified 20 different interaction categories for every bug. For the calculation of distribution uniformity, we have used an established parameter called Gini. Now, Gini is actually something that measures inequality. For example, values closer to 1 reflects maximal inequality, values closer to 0 reflects maximal equality. I'll show you an example. So this is how our data looks like. Bugs and different types of interaction for each bug. Row 1 says that there are two interactions of type 1, 0 interactions of type 2 and 3, 3 interactions of type 4, and so on. For every row, we calculate the Gini coefficient and we come to something like this. Now, Gini is inequality. So 1 minus Gini gives us uniformity. And this is what we arrive at. This is our uniformity of distribution of developer co-commenting interaction across the different categories. Now, we come to our model variables. Let me tell you, this is a causal study. In causal study, we have a treatment variable and we estimate the impact of the treatment variable on the outcome variable. For us, the treatment variable is interaction uniformity and the outcome variable is the bug resolution time. We estimate the impact of the treatment on the outcome in the presence of covariates. Okay. Now, covariates have the potential to impact the outcome. So we need to control for the influence of the covariates so that we can isolate the impact of the treatment on the outcome. For our purpose, we have used inverse probability of treatment weighing. This is an established causal method. The reason we chose this is because it is suitable for studies where the treatment variable is continuous in nature. For example, our variable is continuous in nature. Now, every causal study has two groups, a treatment group and a control group. Subjects who are administered a particular set of dosages are kept in the treatment group, the rest are in the control group. Okay. Now, what IPTW does is it calculates the probability of receiving a treatment and calls that a propensity score. Now, using the inverse of propensity score, IPTW assigns a weight to each subject. Based on that weight, then, the subjects in the treatment group and the control group are matched. After the matching is done, what we arrive at is a pseudo population or a population where the covariates are controlled for, and we can isolate only the impact of the treatment on the outcome. Let me show you an example of matching. First, I will show you an example without IPTW and then with IPTW. So this is without IPTW. We have assumed the propensity score as 0.1, which means probability of treatment is 0.1. So if there are 10 subjects, one subject will be in the treatment group and the rest 9 will be in the control group. This one person in the treatment, one subject in the treatment group is now matched to one subject, randomly picked subject from the control group. And you see the problem, right? This one subject in the control group is representing all the 9 subjects that were there in the control group. Now let's come to IPTW. So with IPTW, again, propensity score is 0.1. Now this treatment group subject is now assigned a weight which is inverse of the probability of treatment or inverse of propensity score, that is 1 by 0.1, which is 10. Each subject in the control group is also assigned a weight, so that is 1 by 1 minus 0.1, which is 1 by 0.9 or 10 by 9. Now you see what I'm arriving at. This one subject in the treatment group has a weight which is equivalent to all the 9 subjects of the control group taken together. 10 by 9 into 9 comes to 10. So we are considering all the subjects in the control group, and we arrive at a population where every subject is equally likely to be in either of the groups. Okay. So this is an overview of the data sets that we have used. So Eclipse, as we know, is a popular integrated development. OpenStack is for cloud computing. This is the amount of data that we have processed for our study, and let us come to the results. We saw from our scatter plots that our variables have a nonlinear relationship among them. We assumed a quadratic relationship, and IPTW is based on regression. We found that our treatment variable has a statistically significant causal relationship with our outcome variable across both the data sets. And we found from the coefficients of the equation that the uniformity, as the uniformity of co-commenting interaction increases, bug resolution time also increases, but up to a certain point. After that, as the uniformity across the different categories increases, resolution time actually decreases. Now, one thing that we can definitely take away from this is that because a causal relationship exists between this diversity of interaction and bug resolution time, we need to consider this as an important marker or as an important factor which has impact on the bug resolution time. Our study considers various threats. We have considered construct validity, internal validity, external validity, and reliability. As far as future work is considered, we have just started with the causal studies in developer interaction, and we tend to look into various other aspects of developer interaction and the causal relationships that exist. Let us come to the conclusion. To the best of our knowledge, this is one of the pioneering studies that has been done, pioneering causal studies, which has been done in the software context, which deals with developer interaction. And we now have causal evidence that our variable, that is distribution of developer interaction, has impact on the bug resolution time. Now, this can provide potentially, I agree, more work requires to be done, but it does provide crucial insights to organizations, managers on how to compose their teams, how diverse should the team be. With their data, with their past history, they could compute what should exactly be the composition of their team to optimize some important software outcomes, for example, bug resolution time. So I thank you all for giving me a patient hearing, and I invite your questions, comments, and feedback.
We have time for a quick question. I mean, I'm trying to reduce the time for every presentation. So, is there any question from the audience?
Can you go to that network, developer network, like
Develop network, that was at the beginning. But I think that's not a novelty for this paper. This you were using more for calculation.
Yes,
I-
yes,
So
yes.
just
I
want
know,
to
sir. I know, sir.
where
Very
from
well.
the network, from the network, can I get that for which bug this network is forming?
That record the when we constructed the developer network at the background we kept a very big CSV file which contained every data for which bug for which developer. Yes.
From the network.
No, from the picture we cannot.
Another thing is that does this the direction of the edge?
No, it does not matter here. No, those they're undirected.
I have a question
Yes.
regarding this one. I think you have categorized the levels of experience and familiarity. Yeah.
Yes.
I think you have familiarized the network with familiarity and experience, the developers.
Yes.
And regarding the experience, I've seen that the frequency of the comments means, say, one person is commenting multiple times in multiple posts, and sometimes it is found in Stack Overflow especially that most of the comments are useless, irrelevant. But still, according to
Much
your
for
methodology,
asking this question. I know where you're going because I have seen we have considered the details are there in the paper, unique comments. So if one person keeps on making meaningless comments on a bug, we have not considered those. These are unique comments for a bug. We had huge amount of data, 25,000, 30,000 for one data set only. So we have the liberty of selecting only unique comments for a bug. So unique comment of a developer in a bug.
by unique comment, you mean which have been appreciated by the persons who have posted the
No,
bugs?
this is not a post. This is there is a difference with Stack Overflow where you can upload and download. Here, there is no scope for that. It's a bug resolution system where the bugs are being logged and the developers are actively working on it. Chances of, and this is a vetted data, so chances of meaningless conversation is less over here. There, it's a different scenario.
Thank you.
Thank you. So, thanks again. So, the next paper is paper code 91, movie recommendation using web crawling. And the presenting author is Chandrasekhar Kumar. For the afternoon session, I suggest if all the authors load their presentations in the laptop and check it during the lunch break. Let's start.
Sorry for the delay. Good morning, sir, and good morning, everyone. I am Chandrasekhar Kumar, and I am here to present on movie recommendation using web crawler. So, my co-authors are Professor Devasish Jana, Ronit Raj, Amit Kumar, Harshit Sekhar, and Katibas Paul. So, these are the contents we will be moving forward, and to start with motivation. So motivation behind this is to enhance user experience and reduce the searching time for watching a movie. So this can be done by reducing the information overload which is already present in the current scenario. So with countless movies available, it is very difficult for the users to find something right to watch which he might be interested in. For example, about on an average 1000 movies are released in India per year, so that makes us about 2 movies per day. So these kind of volume are movies produced in current scenario, so it's not possible for us to see about all these movies and decides which one to watch and which one to not watch. So thus recommendation system helps us to reduce our search area and filter out irrelevant ones so that we can save our effort and time as well. Sometimes user can find some movies that are less popular or which he would not have been otherwise encountered, thus in expanding his or her cinematic experience. So objective of our paper is to design a comprehensive recommendation system that integrates static data sets with the real-time data to enhance relevance and user satisfaction, and to evaluate multiple recommendation techniques and demonstrate the role of web crawling in the recommendation system. So basically, there are three kind of movie recommendation system. So let's start with content-based filtering. In content-based filtering, recommendations are made based on the specific movie features and their metadata. So each movie is represented as a vector, and cosine similarity is calculated, and based on that, top or similar movies are being recommended. Another one is collaborative filtering. This method relies on user interaction and preferences to recommend movies. What it does that it takes a user and puts into a group of user or clusters them into a particular cluster based on the similar taste. So if I am watching a particular movie, so person with the similar taste as me will also be recommended the same movie. So one drawback of this is that to get the preference, generally platforms ask the multiple questions. So as the number of questions will increase, the accuracy of the recommendation, this type of recommendation system also increase. But no one has this kind of patience today to answer this much of questions before watching a movie. So it's not very much it is less preferred. So the third approach is used in this, that is hybrid recommendation system. In that we are using the both method, a combination of the both, to create a balance between the collaborative filtering and content based filtering to effectively recommend a movie. So we are using a web crawling method. So what is web crawling? So it is the process of systematically browsing internet with the help of a program called spiders or crawlers to index and retrieve data from the websites. It plays a vital role in collecting up-to-date information about any movies sites or from about any movie from movie databases or review sites and social media. So basically, what it does that it starts from a seed list. It is called a seed list. It contains a list of URLs. From there, it's first goes in those URLs and takes the data as well as finds new URLs and index them and saves them for further that further repeating this process multiple times to gather multiple comprehensive data about anything, any movies. So there are various web crawling techniques based on the nature of data being crawled. So first one is static crawling, which focuses on collecting predefined structured data from static websites. This is quite helpful where the data is not changing itself frequently. So like the movie and cast and crew and all those things. Another one is dynamic crawling, which takes into account the dynamic nature of the content, like the rating and the review about any movies during course of time. And automated crawlers use the technique tools like Beautiful Soup and Scrapy to design a bot that automatically uh, automatically search and crawl the net and so on. So our methodology is that existing movie recommendation system often lack the real-time data, leading to a gap in capturing the new releasing and trending movies. So, what the current recommend movie recommendations system uses, that it just relies solely on the ML algorithms to recommend a movie. So, if a current movie or upcoming movie, I want to be sure that I would want to watch that or not. So it's not giving me that. So if I am able to get a particular movie which is just released or is going to release, so I will be well aware and will be able to experience in theaters. So I will get a different experience. So this kind of thing with where so this paper, our paper solves the problem by integrating static historical data sets with the real time data to deliver a dynamic movie recommendation system by utilizing both the historical data as well as fresh data. The aim is to create a system that better reflects the current user interest and preferences. So uh, the first process starts with data collection. So there are various ways. One of the ways is through API, and one example is given here. We have gathered the data from Rotten Tomatoes using about a movie from using a API. So the another method to get the data is through web scraping. So this method is, however, sometimes seen as unethical or not in the legal side. So I would recommend that you should consider that factor as well. So what we do that we load the HTML file locally and we save the legal HTML file, and using the tools such as Beautiful Soup, we pass the HTML content and we find the exact or we get the desired uh, data from any website. So here is an example. You can see that we have extracted the data of a director for a movie. So from the IMDb site. So like that, all the relevant information about a movie can be scraped from websites as well. So this was for the dynamic part, and we utilized some historical data. We got the data from Kaggle and applied various ML algorithms on them. Uh, various type of algorithms like collaborative filtering and content-based filtering and hybrid-based approach for different purposes. So yeah, and at my conclusion, I would like to say that we are designing a dynamic recommender system that integrates both the real-time web crawl data with the static data sets to enhance movie recommendations. And real-time data from Rotten Tomatoes and IMDb ensures model stays relevant. So, what we see that whenever a movie is released, so we often rely on the reviews and comments from the people who watch that movie on the YouTube or on many social media sites. So in future works, we include that we will get that those feedback. We will incorporate those feedback into our system so that it will become very. It will better our system. So as the we depend on any person's recommendation, so this will play a major role. So at last, I would like to give you an analogy about this that I would explain this using an analogy. Suppose the now budget is going to be released. So suppose there is a budget has been just released, and I, being a common man, I want to know about budget. I'm not an expert, so I would not go read the whole budget. So each newspaper, suppose there are three newspapers, and each newspaper we know that they have some tilt towards this tilt and biasness towards the issue. So each newspaper will, suppose the first newspaper says that this budget is oppressive on farmers. The second paper says that this budget is oppressive on middle class, and third third paper says that budget is like this. Means it is not good for long term. So if I want to get the comprehensive picture or the any as an informed citizen about the well-doing of the government, so I would gather the I would have to read all those three newspapers. But suppose there is a system that takes the data from all three newspapers and tells that this is the budget, and due to these points, some feel that this is oppressive on farmers, and due to these points, some feel that this is not good in the long run. Suppose thus this system helps and save my time, so that I don't have to read the budget and I don't have to be an expert on on the economics, and thus saves my time and effort. So thank you for all your attention, and thank you, sir. Uh,
Questions? I have a quick question. Is there anybody in the audience? Okay. What exactly, I mean, I'm not sure, I mean, historical data is there, but like you trust that as compared to using some ML technique,
yes.
here you are giving kind of more weightage for fresh data.
Yes.
What do you mean by fresh data?
Fresh data means I want to know that which movies are top movies current this week, or which suppose that there are many movies. Suppose that they are South movies, so I want to know that which South movies are good to watch according to my preference and the preference and choices. So it will give me all the top in that category top movies from that side, and suppose there are 10 sites, so we in the if we want to show the results, so we are incorporating all those data.
So in a sense, you are
taking the
you are depending on, you're assuming some other recommendation system, or I mean, so you're dependent on that. Your
Yes,
result
for
depends
the
on
real-time
that.
part, we are dependent on the like top 10 movies from that IMDb, top 10 movies from Rotten Tomato, top 10 movies from Bollywood, like that from different sites. We are depending on that, and we will be giving more weightage to that. Or
Have you compared your approach, the results that you're getting, vis-a-vis, say, just using some LLMs like where the morning talk was talking about, where this information, the release informations about the movies,
yes,
from there, some semantics are taken and that's compared with the previous trend, and there must be publications which have done that. Have you compared your result vis-a-vis theirs?
no, sir, we have not compared the result. Actually, the accuracy can be determined only if we know that with the feedback of the user. So only then we will be able to determine that how much accurate is it. So I don't know that if I say that this movie
What you're predicting now, after 3 weeks, you'll get the data. How people liked it.
Yes, sir. How
That's
people like it,
obvious.
that I will not know that accuracy because we have no results to compare. So
True.
that's why it will take some time.
Thank you. The next paper is a short paper. Paper code 24, Framework of a Smart Contract System for Improved Supply Chain Management. So the presenting author is Aniket Pal.
Good afternoon, everyone. My name is Aniket Pal, and I'm delighted to present my work on framework of smart contract system for improved supply chain management. So, my project explores how smart contracts on Polygon blockchain can revolutionize supply chain processes, addressing inefficiencies and enhancing transparency, security, and traceability. So, let's get started. So here is the roadmap of my presentation, my today's presentation. So start, we will begin with an introduction to the problem. Then I'll discuss the supply chain management and the potential of blockchain technology involving supply chain. So let's get started with the introduction. The modern supply chain is a complex network involving multiple stakeholder processes and systems. However, traditional methods struggles with inefficiencies like manual processes, lack of transparency, and limited traceability. My research focuses on automating and optimizing supply chains using smart contracts on the Polygon blockchain. The approach enables secure product catalog placements, transmissions, automated order placements, streamlined logistics, and coordination. Our ultimate goal is to ensure seamless coordination between suppliers, buyers, and the carriers, where transparency and trust is ensured at every stage. So, what is a supply chain management system? Supply chain management, or SCM, is the backbone of commerce, modern commerce. It involves the coordination of sourcing, procurement, production, and logistics to deliver products and services efficiently. However, traditional SCM systems often rely on siloed information or centralized informations and manual processes, leading to delays, errors, and increased costs. This underscores the need for a more transparent and automated approach, blockchain technology, which offers transformative solutions we'll discuss next. So here is the block diagram of a blockchain. So what do you mean by a blockchain? as we can say from the word blockchain, it's a chain of blocks. So how the chain of blocks are connected with each other? The hash function, function of the ith block is given to the I plus 1th block. So what is a blockchain? Blockchain is a decentralized ledger system that stores immutable and tamper-proof data. This makes it ideal for supply chain management, where trust and transparency are critical, and also data security. So how a smart contract is deployed on a blockchain? Let's say our money is transferred from Alice to Bob. First, the transaction is transferred to the smart contract code, and the compiler will connect with the smart contract deployed on the blockchain with the API or application binary interface, which helps to interact with the smart contract on the blockchain. So after the transaction is verified between all the peers, as you can see in the picture, there are several computers who are verifying the data is legit and it has been verified, or the transaction has the network validates, and the block has been given to every validators. So what are the traditional challenges in SCM? The traditional challenges in SCM faces mainly three primary challenges: lack of traceability, low transparency, high operational cost. So lack of traceability, difficulty in tracking goods across the supply chain, low transparency, stakeholders operate in silos of centralized manner, leading to miscommunications, high operational costs, manual processes and intermediaries increases the expenses, or third parties involved in the supply chain also increases the cost. Addressing these issues requires a system that automates processes, enhances visibility, and reduces reliance on intermediaries. So, moving on to our proposed solution, we are using smart contracts in the supply chain to enhance the traceability, improve transparency, and cost effectiveness. We are reducing the cost effectiveness by implementing it on the Polygon blockchain, which is a layer 2 blockchain on Ethereum or Ethereum blockchain. So, enhanced traceability, Polygon's blockchain technology allows for real-time tracking of goods and data, improve transparency by utilizing Polygon decentralized ledger. All stakeholders can access a single source of truth. Cost efficiency, smart contracts on the Polygon blockchain automate processes, eliminates intermediaries, and reduces manual intervention, significantly lowering operational costs. So, here is the assumptions of our system logic. Our proposed system has the following assumptions: only owner can register and remove a supplier and update the shipment status of an order. Only verified suppliers can add and update products. Suppliers can update the products only which they added. Buyer can only order a product at a time. Until the payment is done for an order, the shipment status of the specific order cannot be updated, and the payment is directly going from buyer to the supplier without any intermediaries. So why we are proposing the owner is the one who is updating the shipment status, as the owner is the carrier here we are considering. So here is the workflow of the owner. So as we can see, the main workflow of the owner categorizing the 4 different categories. Is it to show all orders? Is it to register a supplier? Is it to remove a supplier, or is it to update the shipment status? For registering a supplier, supplier address is added to the blockchain for registration purposes, and typically like that, the removal of software is removal of the supplier is done by the owner by deleting the address from the blockchain. At any point, if the transaction is not met the requirements, the transaction is reverted, thus maintaining the atomicity of the transaction, thus maintaining also the ACID properties of the transaction. So here is the workflow of the buyer. So buyer can view a product, buyer can view all the suppliers available, and buyer can also place an order and also check if the product is there and from the trusted supplier or not. So here is continuing the buyer workflow. After all the checking is done, the emit order paid event is emitted and the payment is done. So supplier workflow. Supplier workflow is to send the owner to register himself on the blockchain. The supplier can register a product or update a product. Only the registered suppliers can do that. So when a product is added, the emit product event is emitted, and when the update is done to a product of the supplier, an emit product event update status is emitted. So here are the transactions recorded on Polygon MY testnet blockchain. As we can see, the function called registered supplier made by the address on the second address. Second address is the supplier is the smart contract address, and the first address is the owner's address or the one who is deploying the smart contract on the blockchain. So here are the few screenshots of the Polygon transaction. So in conclusion, the integration of smart contracts using Solidity on Polygon blockchain transforms supply chain processes by automating operation, enhancing security, transparency, and efficiency, and traceability. The contract captures transactional data in auditable and transparent manner, enabling effective decision making. Features such as seamless supplier onboarding and removal and real-time product catalog updates ensure adaptability to dynamic businesses and needs, and empower informed purchasing decisions, driving overall supply chain optimization. There are the references of my work. Thank you. Any questions?
Any question? I have a simple question. I understand that you still propose a framework and for deploying. You have a very important word in your title, in the title of the paper, that it's a framework of a smart contract system for improved supply chain management. What's your claim in terms of improvement?
In terms of improvement, we are deploying it on the Polygon blockchain. We can also deploy it on the Ethereum blockchain, which is very costly.
No. So what is the improvement that you will
cost efficiency, and already deploying the supply chain management system on a smart contract enables the traceability, enhancing the traceability, and
cost means cost of mining or
cost of transactions, each transaction or each data procurement or like that something.
Okay, so
Same question. When you were saying you have achieved cost efficiency, is it because just you put blockchain into a traditional system, or you have improved the blockchain system as such?
All the papers we have studied, every supply chain management system was deployed on either Ethereum blockchain, which is very costly, like one Ethereum is equals to 3.6K USD, whereas the Polygon blockchain, the one Ethereum or one Matic, is equivalent to 0.5 USD, which is very cost effective. And no, it is there. As we can see here, the transaction with the Matic value.
Again, that presentation problem. I think this question can be taken during the lunch break. I mean, let's for the sake of brevity. I mean, this is a very interesting point. Thanks to the author again. The next presentation, next two presentations will be online. Unfortunately, we couldn't contact the author for the next presentation, which is paper number 42, automated module for image quality assessment from narrow banding imaging endoscopy cameras. So there's a video that can be played so that at least we get to know about the work. Unfortunately, as we couldn't contact the author, there will be no question and sessions following that. So this is a natural development after the COVID. And in a sense, it's good because sometimes it's not possible for authors to travel.
It's was very good. As good as the offline.
Yeah, I mean, if they're present, then it becomes otherwise it really the point of conferencing is lost without interaction.
Yes, hello and happy new year, everyone. Thank you for being here today. My name is Fernando and I'm discussing our research. Hello and happy new year, everyone. Thank you for being here today. My name is Fernando. Discussing our research on automated modules for image quality assessment in narrow and in image endoscopy camera. We are from FPT University, Hanoi, Vietnam, and we are grateful for the opportunity to present at this event. Gastro intestinal disease are significant global health concern, affecting approximately 40% of the population. This condition can lead to a reduced quality of life and impose financial burden on healthcare system. Early identification can prevent certain outcomes such as cancer and improve patient condition. While endoscopy is widely used, its accuracy is limited due to poor correlation with histological findings and it relies on the endoscopic field. It brings us to the potential of narrow and imaging. MBI improve visualization by utilizing specific library like 415 and 540 nanometers to emphasize vascular structure. This enhancement help in detecting lesions and provide clearer insight for preliminary historical diagnosis. However, despite benefits, image quality can vary, highlighting the need for effective quality assessment. Even the last dataset for MDI many images are substandard with poor changes for strong diagnostic utility. Manual review of this dataset is inefficient and increased cost, underscoring the need for automated solutions. Our objective is to develop a deep learning framework that automates the image quality assessment in NBI endoscopy. This framework aims to improve data quality control, reduce storage needs, and streamline diagnostic processes. We propose a two-stage framework combining pathway classification and aggregation. The backbone of this framework is convolution neural network CNN or robot feature extraction. In the first step, we divide this into 128 by 128 pixel patches and categorize them in four quality types: brightness, backlit, motion blur, and high quality. Evaluating these patches can be tricky due to variability caused by lighting and motion. Our CNN by architecture is redness with leveraged residual connection to extract hierarchical features, allowing to combine both low and high level features.
improving classification accuracy, distinguishing between similar patches like damage and high quality can be challenging. To address this, we implemented feature magnitude not function to enhance separability. In the second step, we determine overall image quality was poor, fair, good, or excellent by aggregating the best classification using statistical methods and breadth first search. This method gives us an overall quality rating for image. To balance the dataset, we apply data augmentation technique such as rotation, flipping, and gamma correction. These methods reduce classification bias and improve model performance. We evaluate the framework using accuracy, precision, recall, and F1 score. Which model changed using Adam optimizer and baseline 32. Our model achieves 97.7% overall accuracy, which improves separability of pass time, as seen in TSD plots. The feature magnitude not function significantly reduce reclassification, particularly for brightest and darkest patches. Here you can see example of fair quality image categorized based on pair distribution. Fair image show uneven lighting, while excellent image exhibits minimal motion blur and high proportion of quality patches. Our framework significantly reduce storage requirement, achieving saving up to 90% in some cases. This demonstrates its potential for optimizing medical data management. Key advantages includes high precision, easy appeal for medical professionals, and adaptability for real-time application, making it a valuable tool for improving diagnostic workflow. The biggest upside may introduce ambiguity, and our evaluation rely on a small pool of experts. We plan to refine the methodology and collaborate with more medical professionals to enhance robustness. In summary, we will develop a robust framework for ultimate image quality assessment, achieving high accuracy and efficiency. This will contribute significantly to medical imaging and endoscopy practice. Finally, I would like to thank you so much for your attention.
So that brings us to an end of this paper because we couldn't get the author. So, and also now we'll be having, would we contact these, the authors for this last paper? You're trying. Okay. Last in, he's online. They are in fact. Yep. So there are the last paper is paper 33, leveraging efficient network. Leveraging efficient net before model with multi-head attentions for maize leaf disease detection. And I get two names to be the presenter, Thota Siddhartha and PVSS Vikram. But they will be presenting it online.
Good. Hello everyone, good morning. Myself Vikrant. Actually, excuse me, the screen share is disabled for the host. I couldn't screen share.
View for the previous video was at very low. So let's start the video.
Yeah, good morning, everyone. Myself, Vikrant. Our presentation topic was leveraging efficient net B4 model with multi-head attentions for maize leaf disease detection. Uh, our paper ID was 33, and the authors are Ishwar, myself, Vikrant, Siddhartha, Kumar, Rimjim, Revant. We are from Amrita University College, Bangalore. The outline of this project was first one, problem statement, introduction, dataset description, implementation, results, results and analysis, conclusion, and future work. Next, references. First, coming to the problem statement, farming faces a significant challenge in the timely and accurate detection of diseases in the efficient crops like maize. Identifying diseases in maize leaves is crucial for ensuring food security, as these crops are a vital part of the global food supply. Vital part of the global food supply. However, the traditional methods for detecting and diagnosing crop diseases are often slow, labor intensive, and lack advanced technological support. As a result, there is an urgent need for more efficient and innovative solutions to address this problem. This study aims to explore and develop a faster and more reliable approach to detecting diseases in maize leaves. Introduction. As the world strives to increase food production, the health of efficient crops like maize faces serious threats from various diseases. Traditional methods of detecting these diseases are time-consuming and labor-intensive. In this study, we aim to explore a modern solution by leveraging advanced computer algorithms which are capable of analyzing images of diseased crops, which are maize leaves. Our objective is to enhance farming efficiency and to protect their crops. Next, to safeguard the vital crops like maize from diseases, we are leveraging an advanced technology which is known as deep learning. We have used deep learning in this project. This approach involves training computers to identify signs of plant illness by analyzing large set of images. By using the deep learning techniques, computers can accurately detect disease symptoms, enable farmers to take timely measures to protect their crops. This not only enhances disease management, but also plays a crucial role in agricultural sustainability and food security. Next, the dataset description. We have actually used there are actually four types of leaves. First one is Barak down, which is also known as leaf spot. This disease where fungi and bacteria infect plants, which we can see here in the image. Downset, these are the healthy leaves, which are green in color. Next, horror down, leaf blight. This is a plant disease that causes the leaves to develop brown or black spots, which we can see in this figure. This is the picture of the leaf blight. Carrot down, leaf rust. This is a plant disease characterized by orange or reddish brown powdery spots on the leaves. This is the image of the leaf rust. Next, coming to the dataset description, our dataset contains 4,000 images of maize leaf diseases, each containing 1,000 images. And we have split the training, validation, and testing 60 is to 20 is to 20, 60 for training, 20 for validation, and 20 for testing. Next, coming to implementation, the dataset. Next, coming to the implementation, the dataset. First one is data augmentation and pre-processing. The dataset is divided into training, validation, and testing to ensure balanced learning and evaluation. Images are resized to 224 into 224 pixels for consistency. Data augmentation techniques like zooming, we have used zoom range 0.15 for shearing, shear range 0.15, and shifting, wide shift range is equal to 0.2. These are applied to enhance model robustness. Next one is model selection. We have selected EfficientNet B4 as a base model due to its high accuracy and computational efficiency in handling image classification. These are well suited for analyzing complex dataset like maze leaf images. Next, coming to the model architecture, a global average pooling layer is added to reduce spatial dimensions, which is followed by dense layer with ReLU activation for classification. This design ensures efficient feature extraction and accurate disease detection. Next, model compilation. The model is compiled using Adam optimizer for stable learning, the categorical cross entropy loss function for multi-class classification, and accuracy as the evaluation metrics to track performance. Next, model training. The model is trained on the augmented training dataset using the fit or fit generator method. Validation data is used to monitor performance and prevent overfitting. Next, coming to model evaluation, the model's performance is evaluated on the testing set using matrices such as accuracy, precision, recall, and F1 score to ensure the reliability in detecting maze leaf disease. Confusion matrix and visualization. A confusion matrix is generated to analyze the model performance for each class, helping identifying areas for improvement and enhancing the overall accuracy. Save and deploy the data. The trained model is saved for future use and deployed, allowing it to be integrated in for real-time disease detection in maize crops. Next, these are the layers we have added in the EfficientNet. First one is global average pooling 2D. The global next is a dense 1024 units and activation ReLU. Third one also dense 1024 and activation ReLU. Fourth one is dense 512 units with activation ReLU. Here we have added a global average pooling 2D to reduce the spatial dimension of EfficientNet's output and focusing on most relevant features. The two dense layers with 1024 units and ReLU activation were added to enhance the model's ability to learn complex patterns from the leaf data. Finally, a dense layer with 512 units and ReLU activation was introduced to further refine feature representations, boosting the model's accuracy and efficiency in classifying leaf diseases. Next, these are the first we have done using global average pooling 2D and two dense layers with 1024, as we said earlier. Here we can see the average F1 score was 95.75% by these four leaf diseases. Next, we have done fine tuning for our model. Fine tuning the multi-head attention is a mechanism used in transformer based architecture, which enables to capture diverse relations and dependencies within input sequences by utilizing multiple parallel attention heads. Each attention head independently computing scores using query, key, and value vectors. We have the num heads, which specifies the number of parallel attention heads keyed in, which determines the dimensity of the key and value vectors for each attention head. Next, result and analysis. Like we can see here, in between the first and second layer, we have added the multi-head detection with num heads is equal to 8 and keyed is equal to 64. As we can see here, we have added in between the dense 1024 units and both the dense 1024 units. Here we have got an average F1 score of 95.50. And we have also plotted training and validation accuracy and training and validation loss. Next, we have added the multi-head attention layer in between 1024 units and dense 512 units. We have got an average F1 score of 95%. Next, coming to this, we have in this we have added two multi-head attention layers, one in between the first two layers and next in between second and third. As we can see here, we have added the multi-head attention layer in between dense 1024 units and dense 1024 units, and next one we have added in between dense 1024 and dense 512 units. Here we have got an average F1 score of 96.75%, which is more compared to other. Next, coming to the resultant analysis. First, without adding any fine tuning, we have got the accuracy of 95.62%. Next, in between the first layer, we have got 95.63%. In between second and third layers, we have got 95.13%, and we have in this we have added two multi-head attention layers in between first and second, and second and third we have got 96.63%, which is more compared to others. We have also plotted a loss and accuracy, validation loss and training loss. Next, coming to the conclusion and future work. Integrating efficient net with additional layers and self-attention mechanism has significantly enhanced our ability to detect maize leaf diseases. This improved model enables early disease detection, supporting better crop management and higher yields, showcasing the transformative potential of advanced AI in agriculture. Looking ahead, we aim to extend our model to identify diseases in wider variety of crops and develop systems that provide real-time alerts to farmers. Additionally, incorporating the weather data, which create user-friendly mobile applications for farmers for detecting the diseases of the maize leaves. These are the references. And, thank you.
Thank you. Can we take questions for this presentation? Is there a microphone that the author will be able to hear? Any question? No. Okay.
Good afternoon. Am I audible?
Vikram, can you hear? There is a question from the audience, but he's trying to get you over microphone. Can you hear him?
Am I audible, Mr. Vikrant?
No, sir, not audible properly.
Okay, thank you.
Well, I have a quick question. I mean, you basically took a data set and then you divided it and validated and finally tested. But there are many groups that works on using similar technology for disease detection on leaf. Have you checked how was the accuracy of your method for other data sets? I mean, what's the dependency of accuracy on this specific data set? I mean, I mean, or you, for every data set you propose to train it and then check for its application. What's your take? I mean, if I have another data set from, say, another farm coming with some set of images, how confident are you to check for the diseases for the leaf image from the leaf images there?
Sir, actually, I'm not audible properly.
Okay, then let's stop this session here. Thank you. Thanks to everybody present here for patient hearing for all these papers. Thanks.
Thank you.
Thank you so much, sir.
for chairing the session and even helping us in the technical difficulties. Now I would request Professor Dr. Shubhashish Majumdar to come to the stage and please felicitate Professor Dr. Nabind Chaki. Thank you, sirs. Now we will have our lunch break of about 45 minutes. So around 1:45, we are meeting here for our next session. Thank you.
পোডিয়ামটা রয়েছে পোডিয়ামের পাশে এদিকে যাওয়া যাবে না ওইখানে গ্রিন দিয়ে চলে যাচ্ছে দেখবেন তোমার স্যার জিজ্ঞেস করবেন ফোন করবো কি বলবো বন্ধ করবো